Welcome to trigonometry. In this first video, we are going to introduce you to angles. And an angle is just another way to measure something. And to create an angle, we use two rays and join them together. A ray is a line segment that goes on forever in one direction. And so when I connect that to another ray where they meet at the same endpoint, that creates our angle, and the angle is how wide it opens. So where the 2 points meet, that is called the vertex. Then the initial side, when you draw the first side and you sweep it open, that first side is called the initial side. And then when you sweep it open, the terminal side is the second ray that's formed. So you draw the first side, you sweep it open, and then you draw the second side. The first side is the initial side, and the second side is the terminal side. The point where they meet together is called the vertex. Now, when you have an angle that's formed because the angle sweeps open in the counterclockwise direction, that's called a positive angle. So positive angles open counterclockwise. If I draw my initial side and then I swing my angle open clockwise, then that forms a negative angle. So negative angles open clockwise while positive angles open counterclockwise. So when we measure angles, two different units of measurement. So just like there's different units of measurement of, say, distance, with distance, like say I wanted to measure the length of my driveway, I could measure that in feet, I could measure that in inches, I could measure it in meters. There's all different units of measurement for distance. For angles, we have two units of measurement called degrees and radians. We're going to talk about degrees first. When we look at a circle, there are 360 degrees in one rotation. And if I look at this so that the center of the circle is at the origin, if I look at 0 degrees, that would be where I draw my initial side, and then I draw my terminal side right on top of it. In other words, I don't swing open anything. That would give me an angle of 0 degrees if I don't swing open at all, and the initial side and the terminal side lie on top of each other. If I swing open from the x-axis, the positive x-axis, if I swing open to the positive y-axis, that would give me a 90-degree angle. If I swing open, let me use a different color here so that it's easy to see. If I swing open from the positive x-axis to the negative x-axis, that would give me 180 degrees. So now my initial side and my terminal side are going in opposite directions. It looks like a line with arrows pointed in both directions. If I swing open to the negative y-axis, that would be 270 degrees. And then if I do my full rotation, that gives me 360 degrees. Now if I did the same thing, but now I go in the clockwise direction, this would be if I was going counterclockwise. So if I go in the clockwise direction, if I start at the positive x-axis and I swing open to the negative y-axis, I'm swinging open negative 90 degrees, whereas before when I opened in the counterclockwise direction and upwards to the positive y-axis, that's positive 90 degrees. So it doesn't mean you have negative angles. The negative and the positive just tells you which way you're swinging open with your angle. So if I started on the positive x-axis and swung all the way open to the negative x-axis, that would be negative 180 degrees. Because it's 180 degrees, but I'm swinging clockwise. I'm swinging open clockwise. So I could follow all those same angles, but if I open in the other direction, they would be considered negative. Now, to discuss the basic angles in radians, one full rotation is 2 pi radians. So if I look at the circle, if I start my initial side on the positive x-axis and I don't swing open at all, so that my initial side and my terminal side are lying on top of each other, that would be 0 radians. Just like 0 degrees. If it doesn't open anything, you have a measure of 0. But now, if I want to see what my angle would be in radians if I open 1/4 of a full swing, I would take 2 pi and divide by 4. That would give me pi over 2, a half pi. So if I swing open 1/4 of the circle, that's an angle of pi over 2 radians. Now, if I swing open half the circle, then that would be 2 pi, which is 1 full rotation, and I divide it by 2, that would be a rotation of pi radians. Then if I swing open 3/4 of the way, 3/2 pi. And then if I, of course, open all the way, 1 full rotation, that would be 2 pi radians. Okay, now that we have a little bit of an understanding of radians and degrees and what the major angles are, we now know 1 full rotation in degrees is 360, where in radians, 1 full rotation is 2 pi. So now we have this relationship that we can use to convert back and forth from degrees to radians or radians to degrees. Just like if I had the measurement of my driveway in inches, but I want to convert it to feet. There are times where you need to convert from unit to unit. So we're going to use this relationship that I know that 360 degrees is the same as 2 pi in radians, but we can also use that same relationship. If I want to reduce that, I can also say, well, half a rotation, if I divide both of those by 2, I can also use that 180 degrees is equivalent to pi. So we can use these as conversion factors to convert back and forth from radians to degrees and degrees to radians. So in the first example, we're going to convert degrees to radians. Okay, so I have 36 degrees. I'm going to put a 1 under that because we're going to be using fractions here, and it's nice to line up our fractions so we don't make mistakes. I want to multiply it by something in order to get rid of the degrees. So I want to use this conversion factor, but I want to make sure that my degrees cancel. So I want to put 180 on the bottom, and I'm going to put pi on the top. Since this is equivalent to 1, I can flip it upside down, it doesn't matter. So on my calculator, if I want to leave this in exact mode, since pi is an irrational number, if I wanted to put it in a decimal form, I would have to round it. So if I want to leave it as an exact number, I would just multiply the 36 over 1 times 1 over 180 and leave the pi there. And so when I take 36 over 1 times 1 over 180, I get 1/5 after I reduce it. That gives me 36 over 180, and then I reduce it to 1/5. So you can write it as 1/5 pi, or you can even write it as pi over 5. Either one is fine. Now, if I wanted to put it in decimal form and round it to get an approximate value, so this is exact value. If I wanted to approximate it, then there is a pi button on your Texas Instrument calculator. If you look right above your division button, there's a little caret symbol. It looks like a little arrow pointing up. And then right above that, in a different color, mine's in blue on my calculator, yours might be in a different color, but right above that little caret symbol, it has the pi symbol. So I could actually take and hit second and hit that button to access pi, and then divide by 5, and I would get an approximate value of 0.628 if I round to 3 decimal places. So this would be considered the approximate value because it's a rounded decimal. Now, I can do the same thing with negative 30. I want to change negative 30 degrees into radians. So I'm going to multiply by pi over 180 because I want to cross off my degrees. So I can get rid of my degrees, and I'm going to take 30 over 180, and when I reduce that, I get 1/6, and because there's a negative there, I want to make sure I keep that negative. So I'm going to have negative 1/6 pi, or I could write it as negative pi over 6. These are the exact values. If I want to give an approximate value, I'd have to use the pi button on my calculator, which is above my division sign. So I would take and hit the second button to access the pi, and then divide by 6, and that would give me an approximate, if we round to 3 places again, that would give me negative 0.524, rounding to 3 places again. Okay, now in the next example, we're going to convert from radians to degrees. So because we want to be left with degrees, we want the degrees to be on the top now when we use our conversion factor. So we could use either 180 degrees over pi, or we could use pi over 180 degrees. So in the case where we want to go from degrees to radians, we want the degrees to be in the denominator for our conversion factor so we can cancel the degrees. Now, when we want to have degrees as our final answer, we want to convert to degrees, we want degrees to be in the numerator. So for these examples, when I convert from radians to degrees, I'm going to use a conversion factor with degrees in the numerator. So I want to take 3 pi over 4, and I want to multiply by 180 degrees over pi. I can cross off the pi's, and then I have 3 times 180 divided by 4, and when I do that, I'm going to be left with 135 degrees. Now for this one, this is in radians, and I know that it's in radians because it doesn't have the little degree symbol. If it has the degree symbol, it's in degrees. If it doesn't have the degree symbol, it's in radians. So I want to change negative 2.1 radians into degrees. So I'm going to multiply by 180 degrees over pi. So I'm going to take negative 2.1 and multiply by 180. That's going to give me negative 378. And then I'm going to multiply on the bottom 1 times pi, which is pi. Now this will give me my exact value. If I want to get an approximate value, I would have to use my pi button on the calculator and take negative 378 and actually divide it on the calculator. So this would give me my answer as an approximate value of negative 120.321 degrees if I rounded to 3 decimal places. So I got to remember to put the little degree sign, and I got to do that up here too. I forgot to do it. And that way we can show by putting that degree symbol up there that it's in degrees versus radians. Now, drawing angles in standard position. If this is my X and Y axis, I can draw angles however I want, as long as I have two rays, they're connected at a vertex where their two endpoints overlap. But if I want the angles to be considered in standard position, then my initial side must be on the positive x-axis, and the vertex must be at the origin. So these are the two requirements that you need in order for your angle to be considered in standard position. So if I were to draw an angle that looks like this, where this is my initial side, and I swing open like this, and this is my terminal side, I can do that, but it's not in standard position. If I draw an angle where it starts on the positive x-axis and then it swings open, this is considered in standard position. Okay, so the vertex has to be at the origin and the initial side has to be on the positive x-axis in order for it to be considered in standard position.